Hi there, it's Andre again. I'm in the process of assembling the new MicroPad version 3 boards, and today I'm going to show you how I'm going to solder these kind of SMD packaged chips. So stay tuned. So in this video I will show you how I do my SMD soldering. And one of those little buggers is this USB chip here, which is the MUX 3421E. You can see it's very tiny compared to the usual size chips that you have. I'm not going to show those are basically, like, you can see the difference here. This is you can use a normal soldering iron with a fine tip and then just solder it pin by pin. That shouldn't be a problem. This one is the same technique. This is the Spartan 6 that I use here, so this has the same pitch, if I remember correctly, as the USB chip. If you look at this, so you can see this is the same pitch between the pins, and so this is I will show you the technique that I'm going to use to solder this chip. So typically you get these either in some foam plastic bag or in package, or in such a cut tape, where basically this is a little foil that protects the chip from falling out, and this is used in the pick and place machines for automatic assembly. So but I'm going to show you how I do this manually. So I'm going to show you the tools that I use, which is this lead-free. Is it focusing? I don't know. I'll put the link in the description if I find it. Solder. I'm using a syringe with flux that I'm going to put on the board here. There's very fine tweezers. You'll see under the microphone, under the scope. I'm using actually a rather big, in a way, 2 mm wide, I think it's called chisel type soldering iron. I cleaned it with this stuff. Of course I'm not using the, I used to be using those sponges and wet them, but I learned that this one, this kind of metal sponge is much better for cleaning soldering iron, so that's what I'm going to use. To fix the pin in position, I'm just using a little bit of solder on the iron, and I'm going to use the tweezers under the microscope and hold it in position so that all the pins place very well. And I didn't have enough solder on my soldering iron, so let's put some more. It's very carefully make sure you don't move it By the way, I actually need to check something. Oh, it's already done. It's already tacked down. Now I moved it a little bit, so I have to keep it here and tack it down some more. There's really a lot of solder on the bottom. Okay, so it's tacked down. I am going to solder it on the other side as well, a little bit. So. Don't worry about bridges or anything. Okay, so and now, and that is really, you just spread on some flux. And of course should be just one line. But anyway, you put on linear iron, put on lots of solder actually. And then put the solder on the bottom side of the iron and tack it on and just put it to the side. And depending on how much solder you had, what you want to make sure is that you can see here is that the solder is flowing from the pin to the pad. But that's all. That was the first side. That's all. That's easy. It's almost more difficult to tack it down in the beginning than to actually solder a couple of pins, and it's probably even quicker than through-hole soldering. What can happen is if one of those pins has a large ground plane attached, or large area of copper, then the pins on the board may not heat up as quickly as they should, and then you may end up in a cold solder joint. So you have to check that. You have to consider that in your design. I had that problem actually with the what's it called? RTC chip on the Ultra CPU board. So I had to resolder all of them because none of the RTC chips was working because the ground connection, I think it was the ground, either it was power or ground, but I think it was ground, wasn't connected at all because there was too much copper plane, and with this technique it didn't heat up enough, didn't take on the solder, and there was no connection. So in the next revision I changed that, gave it a little more trace on the board to the ground plane or power plane, I don't remember. And then yeah, that's it. Not even, there's not even a bridge that I can show you how to fix it. If you got a bridge, or maybe I'll show you anyway. If you got a bridge between two pins, maybe let's just let's see if I can produce one like this. You can see there is a bridge, a short circuit between these two pins. So it's really easy. Here it's important you remove all the solder from your soldering iron, and then you may want to put in some more flux. I have the syringe in one hand and the soldering iron in the other one. And what you do is you just gently heat it up for a little longer until you see that the solder is actually melting, and you just put it away. If that doesn't help, chances are there some solder has been tacked off on the soldering iron, and then you just repeat. So let me see. That's it. Even fixed that short circuit. It gets more interesting when the layout of the board has something like this next to it, because I'm using a very flat angle to actually do the soldering. So, and if you have other parts that are in the way, you should probably think of soldering these SMD parts first, which, well, I forgot. But anyway, I didn't forget, but the process that I have, the testing process, says, okay, I'm checking the video output from the FPGA first before I start going on to the other stuff. So just to make sure the FPGA is okay before wasting maybe parts on and effort soldering stuff, because before I don't know if the FPGA is actually working. So, but here I got lucky, maybe maybe not. Okay. So that seems to have worked. This seems to have worked. So, and that's basically it. The next thing to do is, I forgot to show you, I have a syringe with IPA, and I'm using lots of IPA and some paper towel to clean that, and maybe do that again, because you can see there is some flux residue still left, but you can see how nice those solder joints have worked out. You can use a small brush for that as well. I think it's actually recommended. I don't have it here right now, so I'm just using this one. Just want to give you the feeling that it's not that difficult to actually solder these small pins, because you don't have to do them one by one or whatever. Yeah, doesn't it look nice? So the final step here, that is now to actually validate the connections using a beeper, and you can very quickly go and see you don't have any shorts, and you actually have a connection between the top of the pin and the pad, and you don't press anything, because pressing would potentially increase the connection on a cold joint. A cold joint is difficult to find anyway, but if you have anything where you find you may have scratch the surface or push it down, then you may have you should consider redoing the soldering, which is as you can see, it's really very quick, and you really don't need any kind of special equipment. The last one, the board is too long, so I can't move it all 90-degree angle here, so okay, that looks good. So now what you've seen today is my technique of soldering those very fine pitch SMD chips, like the FPGA, which is a TQFP 144, or this is a TQFP I think 44 or something. And it's really I've really gotten used to it. It's not that difficult. What's more difficult actually almost is doing these bypass caps. I'm going to show you some of those now. Can you see them? Those here. These bypass caps. But even then, they are easy to use with the right tool. And one of the tools here is this something like this, which is a no clean flux pencil. You just use push it on the board. I'll show you in a minute, and then you can just solder it. Let me show it to you. So first of all, you typically get these tiny little capacitors, bypass capacitors, in such a strip that's used by the pick and place machines as well. They're very little, very small buggers, and let me show you. You can see those here on the board, and typically you just pull off that cover here, and then those just fall out into the container that I'm preparing, that I've prepared here. So let's just, and typically I count them, and they're so small. You should probably get a couple of extra, just for the case you're going to miss some, and then you have them in a bag, in a container like this, where you can pick them with the tweezers. To solder these little capacitors, I'm actually using a different soldering iron tip, which is which is a very fine tip. actually. So let me show you. So this is, oops, this is very fine tip that I use. So let's start. First thing is wetting that with some flux from a flux pin. Yeah, it is actually wet. You can barely see it. It's not. Yeah, it helps a little bit. Now picking one of those capacitors from the bin, putting a bit of solder on the iron. Okay, so there you have it. And putting a bit of soldering on the iron. I should probably clean it first. Put some. Okay, and then you can place it with the tweezers and then just tag it on the board. Oops. Okay, that's not how it should work. So, yeah, and then so what's really important here is you need to work under the microscope, or you can go very close with your eyes, but I wouldn't recommend that, depending on your eyesight. Some people like optical binoculars, binocular microscope to get a 3D view. I have this, so the next part is you can just like a normal. That didn't work. Okay. Did it? No, it didn't. So I have to do that again. Sometimes you have to take it out of the and then check it directly. And you just have to. Now you can see. You may have seen the moment when the solder started flowing, and then you can actually solder this so that it looks a little bit better than before for soldering. So I think that's it. Yeah, that concludes the soldering lesson for today. Hope you enjoyed it. Thanks for watching, and see you next time.